Hi everybody. There has been massive news that went under the radar for most AI folks in the past week, and it was the release of Gemini 2.0 FlashThinking. So FlashThinking is part of a families of model that we would call reasoning models. Only a month ago, we only had OpenAI working on these models with O1 and O3. Obviously, DeepSeek R1 shocked the world when they released one of these models for much cheaper, and they made it also open source. But why I think that you need to pay attention for Gemini 2.0 is that first of all, it's really cheap and its context window is massive. So let's dive into both of these aspects, and we will be ending the video by a little demonstration of exactly what you can build with this type of model. So first, let's jump to the pricing. Here, if I compare side by side the Gemini 2.0 pricing with FlashThinking and the pricing of OpenAI O1, we see a massive difference. Let's look at the input pricing. So for 1 million token, you would pay for text 10 cents. If you use the full O1, you would pay for the same amount, $15. Obviously, the full O1 is a full reasoning model that uses a lot of compute. You could say it uses a lot more than Gemini 2.0 FlashThinking. However, if we compare with something like O3 Mini, O3 Mini is really good. It's better than O1, well, better than O1 Mini, and it is supposed to be using less compute. So I think it's fair to say that comparing the mini models, O3 Mini and Gemini FlashThinking 2 is fair. Even then, we get a price difference that is a 10x multipliers. So $1.1 per million token, or 10 cents, that's 10 times as cheaper for Gemini. So I think if you use Gemini, this means that you can create applications that use a lot more thinking, be able to focus more on specific problems, and you'll be able to make your applications for cheaper with, I think, what are really similar results when it comes to benchmarks. We will not be going into benchmarks exactly in this video. I think this will be for a topic for comparison for another video, but I will try to explain why this is relevant, especially when you're building applications. And by the way, this is the same thing for output tokens. If you have here 1 million output tokens, you'll pay 40 cents and you'll pay $4.40 for O3 Mini. So I'm pretty sure somebody over at the Google product and pricing team looked at OpenAI and really thought to themselves, how can we cut the price by 90%? Maybe we cannot compete on hype and we cannot compete on persona, like having the Sam Altman as a founder or something that captures people's imagination. But Google really went here after the enterprise market, the people that want to build, and people who really care more about the fundamentals more than around the hype of the benchmarks. And Gemini is, I think, as good as the other models, even though it's a little bit less as good, but we'll see why they have a big technical advantage in the next few slides. So one thing that I want to take a bit of time on is their superiority when it comes to context windows. So let's imagine that on the left here, this massive graph here is just my entire code base. So this could be a project that is pretty mature. Let's say a project that has 2 or 3 years of development. We have in the project, we have a UI, we have an SQL schema, we have a React code base. And let's see what O1 with its context window or DeepSeek are able to give us. So O1 has a 200,000 token context window and DeepSeek R1 has a 132,000 tokens context window. The example would be that we want to create a table for user settings. You would prompt something like, please help me create a table for user settings. You cannot fit your entire code base into your context window. So an editor like Cursor or Windsurf, they would try to take your query and they would try to find related files in the code base to send to the model. So because you talked about a table, imagine that your code base contains a lot of code about tables. It contains table components. It contains files that create tables inside SQL, inside your database. All of these files, they will be decided about what to bring into the context. What will be decided is how closely do they fit semantically? So how do the words in the code base look like compared to your question? And should I be including them? So if you say you want to create a table and you have this SQL schema that creates a table, they're not really related because you're looking for a user interface table. However, this will be included in your context. So in your precious context of 132,000 tokens, you will have some unrelated massive schema file from SQL that doesn't fit. But with a context window of 1 million token, you are able to fit some of the biggest code bases out there. We are still not reaching the ability to fit a context window that will be the massive enterprise repos, and I'll give you a little bit of example. So let's go over to Sahil, the founder of Gumroad. He posted a really interesting post on X, and it is the amount of tokens on their code bases that they have. So these code bases, they are pretty good real world examples. So Gumroad has been around for, I think, a decade at this point. Gumroad is a really mature code base. It cannot fit in Gemini, but it's 2 million tokens. But their other company repos, they all fit into Gemini. But if we look at what could fit into OpenAI O1 and O3, you could only fit their two smallest repos, and into R1, you could only fit their smallest repo. So this is the massive advantage, simply because when you bring all of your code base, or at least half of your code base, into the model is much better at deciding which information is relevant when producing the output. And when you deal with reasoning models, they are also able to make judgment calls. So these models are not just predicting the next token, but they're predicting the next token when it comes to reasoning and solving a problem. So let's jump into my code editor and we'll see a little bit of an example of how we can use Gemini 2.0 and these reasoning models. All right, so now that we have understood why Gemini 2.0 is so massive as a use, let's have a bit of an overview of what it means in your code base. So if you're not technical, you can also use the UI, but here's a little bit how I was able to use it in what I think is a really massive difference compared to other models. So first of all, creating, an API fetcher for it is pretty easy. So you really just have to pass in regular settings. You have to pass in your API key. Then in the request body, you can have your typical, array of text and conversations. And you have a few configs like the temperature. And then, you just send the fetch with the model that you want with the content of your body and your API key. Or you could also use the Google Cloud SDKs, but I think using fetch in JavaScript is the easiest way. So let's jump into a bit more of an example. This repo is judging hackathon submissions for a customer. So I've automated the process of judging these hackathon submissions. Let's look a bit at what the judge looks like. So there are multiple judges. There are innovation, technical judges. We'll look at the technical judge. The technical judge has to look at the coding to see if it's done properly and if they are using the hackathon sponsor, in this case GaiaNet, which are a decentralized inference provider, if GaiaNet is present in the code base. So what we do is that we have the code base, we have the repo name, and we have a description. So what we'll do is that we will get the full file content. So this is exactly what it is. It is a string of every file with every file name and its content. So it is a massive amount of information. And then we'll give it a file tree. The file tree will be useful for the model to understand the folder structure and how each files are related to each other. So in my prompt, I pass it the project description that somebody gave me, so that the author of the project gave. Then we pass in the file tree. We pass in the massive full repo with the content, which in this case is around 160,000 tokens in this specific example. We pass it then a few prompts to help it tweak and understand. So the Gaia knowledge, this for example was just an export of their docs, which is again a lot of tokens. And we pass it a request to just analyze a few things like the architecture principles, the integration with the sponsor of the repo, of the hackathon, sorry. And lastly, these reasoning models, they thrive a lot on giving them a bit of space, giving them a bit of breathing room to think and reason about. So this is why I just finish with a user instruction that is pretty generic. I say, please analyze the usage of GaiaNet in this repo according to the requirements and produce a final score of 100, combining your full analysis. So let's look at the final results. I saved it in an MD file so you can see, and this is really good. So it was able here, you see, to really look. It even understood that in the full code base, there was not even a GaiaNet integration. So it even understood everything and it came up on its own, with a final weight for a score, for a technical judging score. So why this is awesome is that you can now give models full access to your repo and let them reason about it. They will be able to select with their attention mechanism, they will be able to select exactly what is interesting, what is important for the question. And so there you go. This is why I think that Gemini 2.0 FlashThinking is a massive, massive drop on the community. It's cheaper, it has a bigger context window, So go ahead and build. This is the next wave of innovation, and it's happening right now. Thank you, and please subscribe to the channel, by the way, if you like this video.